For decades, we have pointed our radio telescopes at the velvet darkness, listening for a whisper, a signal, a sign that we are not alone. The math suggested the galaxy should be teeming with voices. The Drake equation promised us neighbors. But what we found was silence, an infinite silence. This is the Fermi paradox. But what if the assumption that the universe inevitably produces life is wrong? Enter the rare Earth hypothesis. It proposes a chilling answer to the great silence, that while simple, single-celled life might be common in the cosmos, like cosmic moss growing in damp corners, complex, intelligent life requires a chain of coincidences so precise, so improbable, that it may have happened only once. We are not just looking for a needle in a haystack. We might be the only needle that ever existed. To bake an apple pie from scratch, you must first invent the universe. But to bake a planet capable of sustaining civilization, you need real estate that is statistically impossible to find. Most of our galaxy is a death trap. If you live too close to the galactic core, the density of stars guarantees you will be sterilized by a supernova or shredded by the gravitational tides of a black hole. If you live too far out in the rim, the universe lacks the metallicity, the heavy elements like iron, silicon, and magnesium needed to build rocky planets and hemoglobin. We exist in the thin, fragile Galactic Habitable Zone, the only slice of the Milky Way where the radiation is low enough to allow DNA to exist, but the heavy elements are abundant enough to build a solid world. We are living in the only safe house in a city on fire. Even if you find the right star, you need a guardian. Earth is an anomaly. We have a moon that is absurdly large compared to our planet size, a feature not seen anywhere else in the inner solar system. This was born from violence, a collision with a Mars-sized planet named Theia. This accident didn't just give us a nightlight, it gave us stability. Without our massive moon acting as a gravitational anchor, Earth's axis would wobble chaotically, flipping the North Pole to the equator and causing climate shifts so violent that complex evolution would be reset every few million years. The moon also drives our tides, the massive oceanic engines that may have pulled life from the sea to the land. Without this freak cosmic accident, Earth would likely be a sterile, spinning top. Beneath our feet lies an engine of liquid iron, churning and rotating to generate the Magnetosphere. This invisible shield is the only thing standing between us and the stripping of our atmosphere by the solar wind. Look at Mars. It lost its magnetic field, and its atmosphere was blown away into deep space, leaving a cold, dead rust ball. But Earth is not just alive on the inside, it is moving. Plate tectonics, a feature unique to Earth and our system, acts as a global thermostat, recycling carbon dioxide and keeping the planet's temperature stable over billions of years. Without this geological conveyor belt, Earth would have boiled like Venus or frozen like Mars. We are walking on a living machine that actively maintains the conditions for our survival. The final hurdle is the great filter of biology. For 2 billion years, life on Earth was nothing but simple slime, Prokaryotes. It seemed content to stay that way forever. Then, in a singular freak event that has seemingly never been repeated in the lab or nature, one simple cell swallowed another, and instead of digesting it, they formed a partnership, the mitochondria. This jump to complex eukaryotic life is so energetic, so improbable, that it might be the hardest step of all. If we are indeed the result of a 1 in a trillion roll of the cosmic dice, then we are not just inhabitants of the universe, we are its only observers. The rare Earth hypothesis leaves us with a heavy burden. If we destroy ourselves, we might be extinguishing the only light of consciousness in the entire galaxy.